Limits as x approach infinity may end up being infinity. What that means is that as the value of x gets arbitrarily large, the value of f of x also gets arbitrarily large. Let's look at an example. Let's look at the example of limit as x tends to infinity of x squared. Again, let's make a table of values. X will be on one side, x squared will be on the other, and we choose x so that x is tending to infinity. So we choose a sequence of values of x here that are getting larger and larger and larger. We could use 10, 100, 1,000, and 10,000 again. And we compute the corresponding values of f of x, and we see that the corresponding values of f of x are getting larger and larger and larger. In fact, you could say they're getting arbitrarily large. You could say that they're approaching infinity, and we can write this as limit as x that tends to infinity of x squared is equal to infinity. In this case, we actually say the limit does not exist, but we clarify the limit does not exist, and in particular how it doesn't exist. It doesn't exist because it goes off to infinity, and we use this symbol notation equals infinity. So this is another rule to remember. The limit as x tends to infinity of x to the k is going to go off to infinity as long as k is greater than 0. Remember that rule too.